Okay, in number one here, you're looking at uh, which of the following bonds exhibit the greatest ionic character. So you have to compare the electronegativity of each of the bonds. Find the electronegativity of hydrogen, the electronegativity of fluorine, subtract them, and compare them to the difference that we discussed that you have in your notes. And if you do that, then you'd find that this was polar, right? You'd find out that this one, well, I'm just going to go ahead and let you figure out which one has the most ionic, which one's going to be closest to ionic. That's the question. So you have to compare those numbers. The next, number two, asks you generally how many valence electrons are needed for atoms to be most stable. Well, you know what that answer is, or you should know. Which type of bonding? Number three, which type of bonding is characteristic of a substance that has a high melting point? You know that. I'm not gonna go over that. It's in your notes. All right. Which compound? I'd like you to make sure you're choosing an answer. The actual answers are going to come later in this video. You'll have all the answers to the whole multiple choice. They're going to be useless if you're not trying to get the right answer now and then compare them to the right answers. And once you compare them right answers, then you have to ask yourself if they're wrong. If your answer is wrong, why was it wrong? That's how you learn, by being wrong, and then figuring out why you're wrong. So here you have ionic, metallic, nonpolar, polar, covalent. Choose, all right? Which compound is ionic? Again, you're going to have to compare. You have to draw them out and then compare electronegativities by subtracting the two electronegativities in the particular bonds. How do you know which atom is bonded to which atom? This goes back to what we've been talking about pretty much forever. You have to decide here, of these two, which one can make the most number of bonds? Well, you'll find out if you look at the number of valence electrons. Chlorine can make one bond, calcium can make two. So you'll have calcium, and then you'll have two chlorines, and calcium will be in the middle. NO2, again, which one's going to be in the middle? It's going to be nitrogen. And you'll have an oxygen and an oxygen, and you'll have a bond like so. You can do the Lewis dot structures if you like, and you'll end up with the same setup. Of course, you'd have 1, 2, and 3, 4, right? HCl, again, you'll have an H, and you'll have a Cl, and you'll have a bond, and of course, 1, 2, 3, 4, 5, 6, 7, 8. So here's sulfur and oxygen in the middle. Which one's going to be in the middle? It's going to be sulfur, and you'll have an oxygen and an oxygen, and they'll be bonding, and they'll be 2, 4, 6, 8, right? So just sketching out the structures, now you know you're going to compare the electronegativity of these two atoms. It's going to be the same electronegativity difference here. So if this one's ionic, then this one's ionic. If this one's polar covalent, then this one's polar covalent. If this is nonpolar, then this one's nonpolar. Now, it turns out that the geometry or the shape of the molecule impacts things. This is not true for any of these. There's the geometry, the molecular geometry really doesn't, it's not something you need to consider here. In chemistry next year, and if you take AP chemistry, then you can worry about molecular geometry and how it impacts polarity. But for right now, I just want you to get the idea. What's the difference between an ionic compound, a polar, and a nonpolar compound? Here it says, in which compound do atoms have the greatest difference in electronegativity? Here again, it's pretty much the same question all the way up and down with all 5 of these, right? What type of bonds are present in a strip of magnesium ribbon? Magnesium ribbon is just magnesium metal, all right? So you can figure that out. Which particles may be gained or lost or shared by an atom when it forms a chemical bond? Here again, is something that you can focus in on. It's not something I need to go over. It's in your notes, and the answers are in the back. Think about it and try to answer. Which particles may be gained, lost, or shared? Okay, we went over that. Two atoms with electronegativity difference of this. The bond forms is what? Which of these, right? You're getting the same kind of questions, aren't you, that we've gone over in class. Which type of bonds are formed when calcium atoms react with oxygen atoms? Here again, you can figure it out. Calcium and oxygen. What's the electronegativity difference of the two? Then choose which of these is your choice. Now remember, I should tell you that coordinate covalent is the same as nonpolar covalent, and this is polar covalent. Which type of bond is formed by the transfer of electrons from one atom to another? I'm not going to answer that. You should know which atoms are most likely to form covalent bonds. Here again, you can answer it. I don't think these questions are very difficult at all. Now here, this is obviously a continuation of the last problem. Which compound contains both covalent and ionic bonds? Here again, you would draw out each of the atoms. Here in the first one, in carbon tetrachloride, you'd put carbon and then chloride, chloride. Remember, carbon has to have 4 bonds. And you would just do the Lewis dot structures and then compare. What kinds of bond is this? What kind of bond is this? What kind of bond is this? And what kind of bond is this? And then once you have all the bonds identified, then you can choose which one of these 4 have both covalent and ionic bonds. You can figure that out. Which oxygen, nitrogen, and fluorine bonds with hydrogen to form molecules. These molecules are attracted to each other by. And again, I'm not going to define those for you. You should make sure you're thinking about this correctly. This question says oxygen, nitrogen, and fluorine bond with hydrogen to form molecules, right? So it would be oxygen and hydrogen, nitrogen and hydrogen, fluorine and hydrogen. So those are the molecules we're talking about. And again, it would be in this case, if you're reading it correctly, hopefully you read it correctly, it would be oxygen and hydrogen, nitrogen and hydrogen, and fluorine and hydrogen. Should be no problem. You should be able to answer that easily. The bond between hydrogen and oxygen and water molecule classified at, again, you should be able to draw out a water molecule. I've drawn it out about 1 million times. Easily answerable if you've been paying attention at all. Which is a nonpolar molecule containing nonpolar covalent bonds. Again, we're back to the original discussion. Draw out the molecule, find out the difference in electronegativity, compare them to our ranges, and decide if they're polar or nonpolar. Those are the steps you're repeatedly doing to answer these questions. Which diagram represents the polar covalent molecule? I mean, is the question different at all? I don't think so. So, here it's just a question. Is it polar, nonpolar, ionic? Is it polar, nonpolar, ionic? And the process is the same. Compare the electronegativity differences, put them into the number set that you've been given, the number ranges, and then ask yourself, where does it fit? Is it more ionic or less ionic? Because remember, we're talking about a range. So you have a range from 0 all the way up to 2.1, and where this is ionic, and this is nonpolar. And so the question is, how ionic is it? And so it's more of a gradient than it is kind of a choosing. Doesn't fit to 0, 1. It's an escalation. It's a gradient. So something can be more ionic or be more nonpolar. All right. Which molecule is nonpolar due to symmetrical distribution of charge? Yeah, this is back to the question. This is the kind of question that makes this question set a little more difficult than I really would like to get into. Well, for a good example of that would be here, carbon dioxide. and I actually gave this to you in class. This is an example of this. Is carbon has actually a double bond to oxygen and a double bond. Let me erase that. A double bond. Carbon has a double bond to oxygen and a double bond to oxygen here. And when you look 2, 4, 6, 8, and 2, 4, 6, 8, and 2, 4, 6, 8, what you find is that because all the forces here, as carbon, as oxygen is being pulled this way, right? The electrons are being pulled this way by oxygen, and are also being pulled this way by oxygen. But as they are pulled this way, the carbon becomes more positive and then pulls back on the electrons. And when carbon pulls back on them, it pushes the electrons in the opposite direction. So what you end up is an even distribution of electrons, because these two oxygens are equally pulling. Oxygen 1 and oxygen 2 are equally pulling on the electrons, so that even though oxygen here is more electronegative than carbon here, you end up with the two oxygens competing with each other, and they're both equal electronegativity, so you get an even distribution of charges, of electrons. You don't have to know this for the test. I'm not going to put it on the test, but it's good that you understand, you have the idea in your head, and I might test the idea. I might ask you about that. Does the distribution of the charge, does the geometry, the molecular geometry, impact how polar or nonpolar a molecule is? And the answer is yes. If you take a look at these two, if you compare the electronegativity between these two atoms, you'd find that oxygen is much more electronegative than carbon, and you might identify it as polar, for instance. But if you did, you'd be, in this particular case, you'd be wrong, because there's two polar bonds, each one pulling away from each other, pulling in opposite directions, evening out the electron distribution. Now, this has been shown to you in that video with the Australian professor who pronounced the molecule methane, and he talked about how methane is actually the bonds are polar, but because they're pulling in opposite directions, they cancel each other out. That's what's happening here with carbon dioxide. So, okay, if you drew these other three, you would see that this is not happening. They're not pulling in opposite directions, and so each of these is then polar, and so. But that's not the point. The point I'm going to give you is that you understand that the geometry of the molecule does impact polarity. I'm not going to ask you any questions. Just going to ask you to draw the correct molecular geometry and decide if there's a symmetrical or asymmetrical distribution of charge. That's not going to be on the test. All right, usually high boiling point of water is due to this is something you should answer easily. It's in the notes. If you have questions, again, we're going to go over this on Thursday. That's tomorrow. We will, if you have questions, I know we have, some of the kids are sick, and you may be absent on Thursday. That's why I'm doing this. We have one student who's going to be absent, is going to be in the hospital with his brother. Please pray for them. We're going to go, this is one of the reasons I'm going through this now in the video, to make sure that student is able to get the information he needs. So make sure that you use this to your advantage as well. All right, which substance will conduct electricity in both solid phase and liquid phase? I'm not going to ask you this question, all right? I'm not really concerned too much about this. It's important that you understand that ionic compounds conduct electricity only when they are in solution with water, because the ions have to actually move around. So that idea you should learn in physical science. But metals conduct electricity all the time. So here, a metal, a silver metal, in solid and in liquid phase will conduct electricity fantastically. Where these ionic compounds and this nonpolar material will not conduct electricity well. So understand that, remember, metallic bonds have this sea of electrons, and so they conduct electricity easily. That's why we use metals in our wires. But these are not, I mean, silver is involved here, but this is an ionic bond, okay? And when it's in an ion, it doesn't really share electrons the way a metal does when it's bonded to itself or other metals. Which formula represents a molecular substance? You should be able to identify that. Remember, molecular substance is something that's covalently bonded. Covalently bonded. So you go ahead and figure that out. All right. Which molecule contains a polar covalent bond? And here you can look at the two. Now, interestingly, here you should know immediately. I'm going to draw something on here that hopefully, if you paid attention in class, you know what it means. Here we go. Smiley face. Remember, every time you see a smiley face, every time you see something, you should be smiling because it really makes your life really easy when you see it. Also, take a look at the charges and think to yourself, back to referencing this problem here. And you know what? If you understand this and you want to go ahead of the class and really, be really ready for chemistry and some advanced biology, you could try to figure out if things are polar or non-polar based on their shape. But you can take a look at this molecule and take a look at this molecule. There's something, first of all, makes it really easy to tell that which one's polar, or actually which one's non-polar. And then the next thing is to look at the geometry to see if the geometry helps you make sense of that as well. Okay. Here we have a continuation of the previous problem. All right. Where is it? Let me see. Yeah. Sorry about having this. Trying to make sure that the problems are visible here. Okay, so the next question is the electrons in a bond between two iodine atoms are shared, and you should be able to answer that easily. Which of the following solid substances contain positive ions immersed in a sea of mobile electrons? I just said it in previous sections, so rewind this and think about it and listen to my words and see if you can look at this and tell which one of these is in a sea of electrons. So here's some short answer questions that you might see on the test. In the box below, draw a correct Lewis dot structure for an atom of hydrogen, an atom of oxygen, a molecule of water. You should be able to do that easily. Remember, you got this in Mr. Despay's class. You also had this in my class, so it should be pretty easy. State here, number 25, state one way in which bond A and B above are the same and one way they are different. Easily, I can't tell you how. You must be able to do this easily. Draw the Lewis electron dot diagrams of two molecules above. Label any partial charges. You should be able to do that. And it's all over your notes. So again, if you're having trouble, see me personally. But I would really question whether you're taking good notes and whether you're paying attention in class. And if you have a problem with attention in class, we should talk about that as well, because we've covered this a great deal. And here you have, it says, is HCl polar or nonpolar molecule? You can figure that out and explain why. You should be able to explain why. I told you the procedures. You need to rewind this and figure it out if you didn't get it the first time. All right, I told you how to figure that out. Here's that smiley face again with this one. Here we go. HCl, you're not going to be able to tell as easily, but Br2. Come on, guys, smiley face. All right. Write the correct IUPAC chemical formula for each of the following compounds. I do not expect you to be able to do that. I will not ask that on the test. You should be able to do it. It's not that hard. Your barium chloride, here's BaCl. Do the Lewis dot structure, come up with the right number. Iron 3, Fe with a plus 3. So what's the electron? That would give you the number of electrons on iron. And then bromide, what's the charge on bromide? It's -3. So come up with, how to Lewis dot structure that. But don't do it if you're confused. Don't worry about it. It's not that big a deal. All right. For this class, I'm not going to ask you in biology to go through and name chemical formulas. I'm going to give you names. Well, my concern is you understanding the difference between polar and nonpolar bonds. All right. Write the IUPAC chemical names of the following compounds. Again, I'm not so concerned about you naming them in the correct IUPAC nomenclature. But no, I think it's important that you understand that they do have different names. I think it's important that you understand that this is sodium, right? Chloride, right? I think it's important. This is magnesium. Oxide, right? I mean, I think it's important that you understand that they have, this is carbon, and this is one that was named earlier, tetra, right? And chloride, and I ran out of room there. But you should be able to know that when you see these things, they're different substances, they have different names, and they have different properties. They're polar, they're nonpolar, they're, a small amount will help you, a small amount might kill you. You know, it all depends on how it reacts and acts inside your body. And with other things. Here it says, metals like copper are often used in electrical wiring. And this you should be able to answer easily. I expect you to be able to answer that. I've said it several times. There were 2 questions about why they're good conductors already in this problem set. Describe the role of valence electrons in, and we're running out of room, sorry. Ionic, all right, so describe the valence electrons in what they do in ionic bonds and covalent bonds and metallic bonds. You should be able to answer that. In the laboratory, a student compares properties of unknown solids. The results is experiment reported in a data table. So here you'll have some substances. Here's some qualities that they've noticed. Predict the type of bonding happening in substance A. This is what's going on. This is the melting point. This is a water solubility. This is hardness. This is electroconductivity. So tell me, what kind of bonding is happening in this substance? Predict it. Given the binary, remember, when you predict something, don't just make wild guesses. We look at evidence, we compare them to things, our understanding of materials, and we say, this is so, therefore this is so. All right. Given the binary compound formed from magnesium and chloride, don't worry, again, I'm going to even just put a line through it. Don't worry about the IUPAC name. If you want to try, go ahead. So, I mean, I'll give it to you. It's magnesium chloride. Right? So it would be magnesium chloride here, whether it's IUPAC or not. IUPAC is a chemical organization. It's International Union of Applied Chemistry. But don't worry. Whether it's correct or not, according to their nomenclature, is not relevant for biology. It's important, but it's beyond the scope of the class, and you have other things that are more important to learn right now. Write the correct chemical formula for this compound, and you can figure that out. I think you could figure that out. I think you could figure that it'd be Mg, and then you'd have Cl, and you'd have to figure out how many in each. Now, the reason that this is different from the Lewis dot structures and bonds that we've covered with the other molecules is that when you're dealing with transition metals, they can have a differing number of electrons in their outer shell, their valence shell. That's why Mr. Desipeda and I, we haven't told you, we said that the transition metals, this section in the middle, that they don't fall into that. If it's in the group, that's how many valence electrons they have. That's not true for those transition metals. It's not true for magnesium. It is true for chlorine. So we know that, but not necessarily for magnesium. And there's a whole system, a whole kind of logic to it. It's not that hard, but again, it's beyond the scope of this class. It really isn't necessary for right now. You'll learn it later. What type of bonds between magnesium and chloride? Again, you can compare electronegativity. And I'm not going to tell you how to do it again, but I'm sure you can answer C, even though you don't know what's going on with the actual number of them. You can compare electronegativity to magnesium and chloride, and you can make that decision here for sure. So this is something I would expect you to be able to do, right? And how easy, and here as we're going through these practice problems, ask yourself, how could he change these questions to make a new test? Because that's what I'm going to do. I'm going to look at these questions. I'm going to say, how can I change these questions just a little bit, so that I can test whether the kid understands it or not. I don't want you to memorize these questions. I just want you to be able to figure them out. In the boxes below, draw Lewis dot structures of the elements magnesium and chloride. Go ahead and try. I think it's a good experience to try. I'm going to tell you, you may be right. Magnesium has has a very again, it's a transition metal, but you'll be able to figure it out. In the box below, draw the Lewis dot structure for the compound formed between magnesium and chloride, including charges or partial charges. You can do that, I think. Explain the terms of electronegativity. HF bond expected more polar than HI bonds. There again, you should be able to do that. Given the reaction here, which statement, and this is hydrogen and chloride making hydrochloric acid. These two are coming together. What type of reaction would that be? In which statement best describes the energy change in the bonds is formed and broken in this reaction? Take a look at this and figure it out. When phosphorus and chlorine atoms combine in molecule PCl3, 6 electrons will be figured out. You should be able to tell what's going on, because this again is the same question over and over different ways. Here it says in the box below, draw a Lewis. I'm on a field trip, and some kids in the hallway are not very polite. So in the box below, draw a Lewis electron dot structure of a molecule of hydrogen. You should be able to draw that molecule out pretty easily. Okay, so now we have all the answers. Well, here's a set of questions, and then this would be the kind of thing you would have. Of course, you'll actually have a matrix to fill in your dots. A Scantron sheet to fill in your bubble sheet to fill in your answers, and you'll have a separate sheet of paper for the write-ins and the short answers. So again, this is more like what the test. Here's some more questions: what the test will look like, and more on what the test will look like. And again, this is from a gentleman called Mr. Douglas. But you look at, here are all the answers that you should have gotten or come close to getting. I want to remind you that this kind of nomenclature is not necessary for your particular exam, but that will be coming next year. Here again, all right, dinitrogen trisulfide, carbon tetrachloride, sodium hydroxide, magnesium oxide, right? And you can read those, and here's the Lewis dot structure, right, of magnesium chloride. All right, so again, and there are your answers, okay? Okay, well, I hope that this helped. I hope this video, you have all the answers. You walked through it. I've walked you through the reasoning. Hopefully you've listened. Hopefully you have good notes that you can help you study. If you have issues, see me tomorrow for tutoring, or if you're absent, like I know that one young man, his brother's having surgery, so pray for him. He needs this video done, so I made it for him, but I shared it with all of you. If you're going to be absent, you can email me. You can email me any questions you have after you're done with the video. All right, but your test is going to look a lot like this, so make sure you're able to do everything in this practice exam. All right, have a great day.